Dear students, this is Dr. K. Saravanan, Associate Professor, Department of Information Technology, R&D Engineering College. My dear students, now we are going to discuss about Usart in detail. Usart stands for Universal Synchronous Asynchronous Receiver and Transmitter. It is a programmable chip designed for synchronous and asynchronous serial data transmission, which consists of 28-pin depth, which will convert the parallel data into serial streams of bit suitable for serial transmission, and receives a serial streams of bit and convert into a parallel data byte to be read by the microprocessor. This is the pin diagram of your Usart. The pin number D0 to D7, that is data bus, which is a parallel data, and C/to D bar is a control register or data buffer select. Read bar is a read control signals, and write bar for the write control, and CS bar is chip select, and clock for the clock pulses, and reset is if you want to reset 8251 by the external peripheral devices, we can reset by using the pin number 21. TC transmitter clock. This transmitter clock is available at the pin number 9, and RC is a receiver clock, and RD is a receiver data, and RRDY is a receiver ready, and RTRDY is the transmitter ready. That is, the receiver ready means the 8051 is ready to receive the data, and 8051 if it is ready to transmit the data, the pin RTRDY will be get enabled. And DSR stands for data set ready, and DTR stands for data terminal ready, and synchronous detect SYNDET. BRKDET stands for break detect, and RTS stands for request to send data, and CTS stands for clear to send data, and TMT is a transmitter empty, and VCC is supply, and G is the ground. This is the block diagram of your Usart. This block diagram consists of 5 sections. One is a read-write control logic. And read-write control logic, it determines the functions according to the control word, which is the interface the chip with MPU, and it will monitor the data flow too. And next section is transmitter. What this transmitter is going to do, it will convert a parallel word received from the MPU into serial bits and transmit serial bits over the TD line to our peripheral devices. And next section is receiver serial bits from peripheral, and it converts the received serial bits into parallel word and transfer the parallel word to the MPU. And next section, the fourth one, is the data bus buffer. The data bus buffer is the 8-bit bidirectional where you can able to transfer the data as well as we can able to receive the data. The modem controller is used to establish data communications modem over the telephone line. And coming to the chip select CS, which we already seen before, when this signal goes low, the 8251 is selected by MPU for communications. The C/D bar, that is control/data. When the signal is high, the control register or the data or the status register is addressed. When it is low, the data buffer is addressed. The control and status registers are differentiated by WR bar and RD bar signals. The WR bar is a read signals, and RD bar is the write signals. The write signal is used to control register or to send output to the data buffer. This is connected to IOW or MEMW. IO write or MEM memory write. RD bar is a read. Either reads the status from status register or accepts data from the data buffer. This is connected by either IOR or MEMR, that is input output read or memory read. And reset is used to reset your 8251. And clock signal is connected to the system clock necessary for communications with the microprocessor. So coming to these functions, when CS bar is 0 and C/D bar is 1 and RD bar is 1 and WR bar is 0, the MPU writes instructions in the control register. When it is 0101, the MPU reads status from the status register. When it is 0010, the MPU outputs the data to the data buffer. When it is 0001, the MPU accepts data from the data buffer. When its CS is 1 and whatever it is C slash D bar is 0 or 1, or RD bar is 0 bar 1, or WR is 0 or 1. So don't care conditions. Whenever the CS bar is 1, the USART is not selected. The control register, 16-bit register. This register can be accessed and output put when the C slash D bar pin is high. And the next one is status register, checks ready status of the peripheral. And next one is the data buffer, and this data buffer accepts the parallel data and converts into a serial data. Two registers, which is in the transmit sections, buffer register and output register. What this buffer register is going to do, it holds the 8 bits, and output register converts the 8 bit into the streams of serial bits. That last one is transmit data and TD pin with appropriate framing words, which we call as start and stop. Thank you students for listening to the lecture. Thank you once again.